Welcome to all. Now we'll see second problem on penalty method, and this is one of the important problem. It's weighting question paper problem. A bar loaded shown in figure. Young's modulus is 200 GPa using penalty method of boundary condition. Find nodal displacement, reaction and stress. So this is the bar they given. You can see this bar is uniform bar. It is fixed, arranged at this fixed and at left hand side, and there is a gap between the one more support on the right hand side, and in between that bar and the support there is a gap. So the same time problem we solved in using elimination method. So this again we are going to solve same type of problem. We are using a penalty approach. So this type of gap problem is very important. Now this is the 60 kiloton is acting at the center, and it's having a uniform area of 250 mm square, 150 150. So therefore with respect to this load point we are going to divide into two elements. So therefore corresponding to that we are going to write E as 200 into 10 raised to the Newton per mm square. So L1 is 150, L1 equal to L2 equal to 150, A1 A2 equal to 250, and this is the gap. So let's call this X or A. Now we need to find nodal displacement, reaction and stress. So we need to model first FEM model divided into two elements. Corresponding node displacement are Q1, Q2, Q3. So second step is element stiffness matrix. K1 is E1 by L1, 1 minus 1 minus 1. If substitute corresponding values, then we got 10 power 5, 3.33, minus 3.33, minus 3.33, plus 3.33. So only K2 we need to calculate for element 2, that is A2 E2 by L2. So substitute the corresponding values. Anyway, all the A2 E2 L2 are same. So therefore we got the same stiffness matrix. Now we are going to add it, K1 plus K2. We got the global stiffness matrix. So global force vector is at node 1 F1 is 0, at node 2 F2 is 16 to 10 raised to 3 Newton, and F3 is 0. Similarly, global displacement vectors Q1, Q2, Q3 are unknowns. And equilibrium equation we need to write KQ is equal to F. Substitute the KQF value. Now next step is important, that is we need to apply the boundary condition using a penalty approach. So here node 1 is fixed, and node 3 having a displacement. When you are going to apply this 60 kiloton, so there is the node 3 is going to take a displacement freely up to the distance of 0.12. Therefore we can write Q1 Q3 as 0.12 or equal to A3, that is the displacement, free displacement at node 3. Therefore we need to apply the penalty C in stiffness matrix as well as in a global stiffness matrix as well as in a global force vector. So that C we need to calculate by considering the largest stiffness value in the global stiffness matrix. What is the largest stiffness value? So here out of this largest stiffness is 6.66 into 10 raised to 5, that is K22 value. So therefore C become 6.6 into 10 raised to 5 into 10 raised to 4, that is 6.6 into 10 raised to 5. So this C value we need to add it in a global stiffness matrix at node 1 as well as node 3. So therefore that is K13, K11 as well as K33, that we need to add. And also we need to force vector, we need to calculate global force vector, that is at node 1 and node 3. Node 1 become F1 plus CA1 and node 3 F3 plus CA3. Here A1 is 0 but A3 is not 0. In previous problem A3 is 0. Why? Because there is no free displacement, but here there is a free displacement because of this gap. A1 is no free displacement, but here there is a displacement at node 3. Therefore that gap is nothing but A3, that is nothing but 0.6. Therefore it is not equal to 0. That is what we written, free displacement, the gap. Therefore the modified equilibrium equation become KQ equal to, now we have added the C at K11 and K33 and in a global force vector at node 1 and node 3. Now finally substitute the value of C here, and here 10 raised to 9 is there, keep this in mind. So we taken here 10 raised to 5 is common, therefore remaining become 10 raised to 4. And also here total becomes 0 because f1 is also 0 as well as a1 also 0. Here f3 is 0 but a3 is there, keep this in mind, that ac is 6.66 into 10 raised to 9. Don't write again 10 raised to 4 here because 10 raised to 4 y written, 10 raised to 5 taken common, but we need to write here 6.66 into 10 raised to 9 into a3. A3 is 0.12. Now you can solve it. You can solve this. Then we can get q1 as 7.5 into 10 raised to minus 6 and q3 as 0.120015 mm and qt as 0.150095 mm. And finally we need to calculate stress E1 into B1. So epsilon 1 is the B1 into Q, and that is B1 is 1 by L1 1 minus 1 Q1 Q2. So it become 199 megapascal. Similarly sigma 2 become minus 39.9 megapascal. That is compression. Element 1 under tension, element 2 under compression. And finally we need to calculate the reaction, that is reaction R1 at node 1 and node 3, because only it is fixed points we are get the reaction. R1 is minus C, Q1 minus A1, anyway A1 is 0, therefore minus C into Q1, that is become minus 49,950 Newton. So why R3? Because see now when bar is freely extended up to this gap, when come to here, when extended up to this support, there is a reaction going to be developed, therefore R3 also present. Therefore that R3 is minus C Q3 minus A3. Your A3 is not 0, that is 0.12 gap value. Therefore R3 become minus 9.9 into 10 raised to 3. So we'll verify this. See what is the total applied force? Total applied force is 60, right? 60,000. Now we'll verify this. 49 points out of 50 plus 60 is there. 49 kilonewton plus 29 kilonewton, that is become 60. So therefore applied force is equal to reaction. Problem is right. So that's all about the problems. Have few more problems, that is a similar, that I will give an exercise problem. So I will give as an assignment, you can do it. So this complete the problems on penalty method.